Hello there. We're getting ready to start one of my favorite chapters of the year, and that is chapter 6, which talks about how to solve systems of equations. And what we're going to do is actually learn 3 different methods of how to solve systems of equations. And the first method we're going to talk about today in section 1 is graphing. So first of all, a system of linear equations is when you have 2 or more linear equations that have 2 or more variables. And then what we'll be looking for is the solution to the system of linear equations, and that's an ordered pair that makes both equations in the system true. So what we're going to start out with is just looking at solutions of systems. And in order to do this, we take an ordered pair and we plug it into the equations that we're given. And if it makes each equation true, then it is in fact a solution of the system. So let's take a look at the first example here. You can see I have 2 equations and then the ordered pair 5, 2. Remember that x always comes first, so x is 5 and y is 2. So all I'm going to do is plug in 5 for x, so I have 2/5 times 5 minus, and I'm going to plug in 2 for y, minus 2. And that is supposed to equal 0. Well, let's check if it does. 2/5 times 5 is 2, and then I have 2 minus 2, which is in fact 0, so that works. Now it's got to be true in both equations, so let's look at another one. Okay, so 3 times 5 minus 2, and that's supposed to equal 13. Well, 3 times 5 is 15, minus 2, and as you can see, that does in fact equal 13. So this ordered pair makes both equations true, so this would be a solution to that particular system. And that's all we're going to do to start out, is just say, okay, is this ordered pair a solution? So let's look at another example here. So once again, I'm going to take these values that I'm given, x and y, and plug them into my equation. So I got negative 2 plus 3 times 2 equals 4. So negative 2 plus 6 equals 4. And negative 2 plus 6 is in fact 4, so it works in my first equation. Now let's look at the second one. We have negative x. So remember, that's like negative 1 times x. So this is really like negative 1 times negative 2 plus 2 equals 2. So negative 1 times negative 2 is 2, plus 2 equals 2. As you can see, this does not work because I get 4, and that is not equal to 2. So negative 2, 2 is not a solution of this particular system. Okay, so that's how we do the first type of problem you're going to see today, is just plug in the values for x and y and state whether or not it is in fact a solution. Now to the fun stuff. Now when we're solving a system by graphing, we have kind of a step-by-step process we need to follow, and what we're looking for is where do our lines intersect, because the point at which they intersect is the point at which both equations are true. So the very first thing that we have to do is just to graph each equation. And we've been working a lot in chapters 4 and chapter 5 about graphing. So hopefully we're getting pretty good at this by now. Second thing we're going to do is figure out where they intersect. And then the third thing we're going to want to do is check our answer. Because we'll be able to know without having to look at the answer book or ask the teacher or anything like that whether we got it right by checking our answer. So let's look at an example. So here we have the equations y equals x and y equals negative 2x minus 3. Now notice that both of these are in slope-intercept form, which if you'll remember is y equals mx plus b. So they're both ready to graph. Remember, this is y equals 1x plus 0, so I'm going to start at 0, and then my slope is up 1 over 1. And again, I just like to make lots of dots, so that I have really straight lines. And it's very important in this that we have really straight lines, because if you don't, you're not going to end up with the right answer. So here's my line for y equals x. Now let's look at the second one here. This one has a y-intercept of -3 and a slope of -2. So I got to go down 2 over 1. And again, I just like to make lots of dots so that I have nice straight lines. So if I draw that line, I have that. Now, remember that the second step after we graph is to figure out where do they intersect. And you can see that they intersect right at this point right here. So what is that ordered pair? Well, that ordered pair is -1, -1. So that is my potential answer. Now I'm not sure if that's right, so what I can do is I can check it in my equation. So I had the equation y equals x. So if I plug -1 in for each of those, that works. Okay, then I have y equals -2x minus 3. So that would be -1 equals -2 times -1 minus 3. This one requires just a little bit more work. So -1 equals 2 minus 3, which is -1. So that works. So I know that I do in fact have the correct answer. Okay? Now of course they get a little bit more difficult because they're going to start to give you equations that aren't already in slope-intercept form. And there's a couple ways that we can graph those lines, and we'll talk about that in just a second. But let's start with this first line here that's already in slope-intercept form. So remember, since there's not a number in front of x, that means it's 1. So this one has a y-intercept of -2, slope of 1 over 1. So that line looks like this. And again, I want to make sure that I draw really straight lines, or else I'm not going to get the right answers. Now here I have an equation in standard form. So there's a couple things I could do. I could solve it for y by subtracting 2x. And that would give me y equals -2x plus 1. So now it's in slope-intercept form. Now I know some of you really don't like solving for y. Another way that we could do it is with intercepts, and we learned that back in 5-2. So if you want to know the intercept way, ask me about that tomorrow in class, and we'll go over what that would look like as well. So here, this is in slope-intercept form. It's going to start at 1 and go down 2 over 1. Down 2 over 1. And again, I want to make sure I have nice straight lines. So I'm going to draw that line here. Okay. And I can see that they intersect right here, which is the point 1, -1. So again, that's what I think my answer is, but let's check it. So I have y equals x minus 2. So that would be -1 equals 1 minus 2, which is in fact -1. So that works. And then I have y equals -2x plus 1. So I'd have -1 equals -2 times 1 plus 1, which would be -2 plus 1, and that is -1, so that also works. So once again, I know right away that I have the right answer. Now here's another example where they're both in slope-intercept form, and I want you to try this one on your own. The answer you should get is -2, 3. So go ahead and do that one on your own and see if you in fact do get that answer. And I'm going to do one more example here where it's not solved in slope-intercept form already. So the first one is, so let's start there. That one's going to start at -3 and go up 1 over 3. Up 1 over 3. So that line looks like this. Okay. Now again, I could do this either way, either the intercept way or by solving for y. And once again, if you want to know the intercept way, just bring it up tomorrow at the beginning of class and I will review that for you. So if I solve this one for y, I get y equals -2x plus 4. So that one's going to start at 4 and go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. So that line looks like this. And as you can see, they intersect right here, and that's the point 3, -2. Now again, I think that's my answer. I think I graphed them right, but I can check it. So if I have the first equation, which is 1/3 x minus 3, that'd be -2 equals 1/3 times 3 minus 3. So that would be 1 minus 3, and that does equal -2. So it works in the first one, and if I check the second one, y equals -2x plus 4, I'd get -2 equals -2 times 3 plus 4, which would be -6 plus 4, which would be -2. So that works. So I know that I have the correct answer. Alright, so that's how we solve systems using graphing. And tomorrow we're going to keep going in 6-1 and talk about story problems. So we'll see you then.